In the next question, what is given is X gas reacts with 2Y gas giving Z gas, a general reversible system. At constant temperature, equilibrium concentrations of X and Y are given 3 molar and 4 molar respectively. And the system is disturbed by changing volume of the vessel being doubled. When the volume of the vessel is doubled and at new equilibrium, when the system reattains the equilibrium, concentration of Y is found to be 3 molar. Then what will be the new equilibrium concentration of X? So here the volume of the vessel is doubled. Then how is the equilibrium system is disturbed? And what will be the change in the concentrations of Y and X? Y is given, X is asked. So the system is X gas plus 2Y gas giving Z gas. This is the system given. And at equilibrium, at the time of equilibrium, X and Y are, this is 3 molar concentration, this is Y 4 molar concentration respectively, and we are not given anything about Z. So let us assume that by the time when equilibrium is attained, Z is at X molar concentration. Because the system is already at equilibrium, we cannot have the system without any concentration of Z. So let X molar be the concentration of Z at equilibrium stage. So this is important. So now we know the equilibrium concentrations of all X, Y and Z. So what will be the equilibrium constant Kc? That is in terms of active masses. We can write it as X, the concentration of Z, by the concentration of X, that is 3 molar. 2Y is there in the system. Therefore, we can write it as 4 to the power of 2. That is 16 into 3, 48. X by 48 is the equilibrium constant, which will remain constant even if the volume of the vessel is doubled or reduced to half. Because Kc is constant, does not depend upon the volume of the vessel. Now, when the volume of the vessel is doubled, what will happen? The moment volume of the vessel is doubled, double the volume is available for substances X, Y and Z, and the concentrations become half. Therefore, when the volume of vessel is doubled, concentrations become half of initial concentrations. So this is one change that is going to take place. So momentarily the equilibrium will be disturbed. Let us now write the concentrations of X, Y and Z the moment the volume of the vessel is doubled. Thus for the system X plus 2Y giving Z, the concentration which was there for X as 3m now will become 3m by 2, and for Y concentration it will be half of what it was 4m, and Z it is xm by 2. M represents the molarity. So these are the new concentrations the moment volume of the vessel is doubled. But because of this disturbance in concentrations, will the equilibrium will shift onto the left hand side or onto the right hand side? How do you know? So the best method is to work out the reaction quotient Q and check whether that Q is more than K, less than K, equal to K. So therefore, when the concentrations are disturbed, what will be the Q? So it will be concentration of Z, that is X by 2. Then what do we have? Here remember this X which we have assumed as the concentration, this X is a original substance. There is a difference between the two. And then the concentration of original X is 3m by 2, which can be written as 3 into 2. This is X, this is into 2. And then 4m by 2, that is 4 into 4, because it's square, by 2, 2 into 2. So this is the Q. Let there be no confusion between X and into. So now this 2 gets cancelled. 2 into 2, 4, this gets cancelled, and we are getting it as X by 12. So this is reaction quotient. And now when we compare this reaction quotient X by 12 with that of equilibrium constant X by 48, what do we find? The reaction quotient Q, that is X by 12, is more than K. Therefore, Q is greater than K. And whenever Q is greater than K, the backward direction reaction is favored. Let us now assume, because of this shift in the equilibrium to the left hand side, that is backward direction, some Y moles of or Y molar concentration of Z is reacted to give X and Y. So that this concentration now at new equilibrium becomes X by 2 minus Y. Then as Y parts of Z reacted, we get Y parts of X because stoichiometric coefficients of Z and X is same. So this will become 3m by 2 plus Ym. And what about this? For every one part of Z gives two parts of Y. So Y parts will give two Y parts. Therefore, this Y part will become 4m. M stands for only concentration. So 4m by 2 plus 2Y. So these are the new equilibrium concentrations in terms of X and Y. But we are given in the question that the new equilibrium concentration of Y is found to be 3 molar. So let us use that. Therefore, 4m by 2, that is 4 by 2 plus 2y is equal to 3 molar. This is 2 plus 2y is equal to 3. Therefore, 2y is equal to 1. Therefore, y is equal to half, that is 0.5 molar. But what is that we are asked in the question? What is the new equilibrium concentration of this X is asked. So what is it? So new equilibrium concentration of X is 3m by 2 plus Y. So therefore new equilibrium concentration of the substance X is 3m by 2, m is molarity, plus Y. Plus Y, how much we got? 0.5, that is half m. In other words, 3 by 2m plus 1 by 2m, that is 2m. So thus the new equilibrium concentration of X is 2 molar. Whereas the options are given as 2.5, wrong, 2 molar. So here is the concentration of X, which is 2 molar. Therefore B is the right option. C 3.5 wrong, D 4 wrong.